All right, so we knew what he meant. So we are gonna go over last night's homework. How'd you feel about it, those of you who did it?
It was hard. It was really hard.
Okay, so my guess is if you did it, you realized that homework was not difficult. All you had to do was follow along with the earth science reference table. The first one, we wanted a knot, and I'm not gonna do all of these, I'm just gonna demonstrate. Yeah, you got it right here. So the first one gave us some direction that said it was non-metallic. So this is very similar to what we'd be doing in lab. So you knew it was non-metallic, so we know it was not any of these at the top. I also like to get rid of or identify it as the either one right away based on the color. Remember that either one is metallic silver or earthy red. This one's white to pink, so not the either one. Then it tells us it has a hardness of 6. So this really, when they just flat out tell us the hardness, we can eliminate quite a few. So it's not anything less than 6. It's not anything more than 6. There are still 4 choices though. So if we keep going, the only other thing they said was the color, white to pink. So it's not this one, black to dark green, not black to dark green. White to pink is a choice. White to gray could also have been a choice. And
No, just like.
just white. Okay, so it just clearly said white to pink. Okay. So right off the bat, it is potassium feldspar. Then you did have to fill in the composition, which yes, you have to write everything that's there. So the KALSI308, again, keeping capitals, capitals and lowercase, lowercase. So that would be that one, potassium feldspar. Now I'm gonna go kind of quick for the rest of them, because my guess is if you did them, you got it right. Please speak up if you notice something wrong or if you need some help on one of them. So the next one down would have been that sulfur, which is also non-metallic, yellow amber. The next one was fluorite, which is non-metallic, CaF2. The next one is galena, PBS is the only thing to fill in there. Next one down is already labeled talc. Talc is non-metallic one, and it's white to green. Hematite is the one that could be 1 or 6.5. So it's either and silver or red. Selenite gypsum is the next one. Then we got fluorite repeated itself. So I hope that didn't trick any of you that I used the same one twice. We have a hardness of 4, colorless to variable, and fluorite. Pyrite's the next one, metallic 6.5, FeS2. Then we have garnet, which is non-metallic 6.5 to 7, and graphite, which is metallic 1 to 2, and silver or gray. Calcite, which is CaCO3, magnetite Fe3O4, olivine, non-metallic, green, gray, or brown, and that's it for there. How about you guys? Which one bubbled with acid when powdered? Dolomite. Did anybody put calcite? No, because calcite just bubbles with acid anyway. So bubbles with acid when powdered is dolomite. Did you find which one cleaves at 56 and 124 degrees?
The one that starts with an A.
Starts with an A, ends with an E, that's amphibole. And again, that is just right, word for word, cleaves at 56 and 120 degrees. That means the angles are 56 and 100 degrees, so not perfect 90-degree angles. Food additive melts ice. Phthalate. Easily scratched by a fingernail. Again, that, yep, it is right there. Easily scratched by a fingernail. That's selenite gypsum. I already did the next one. Hematite is the red-brown streak. There were 2 that feel greasy, talc and or graphite. As long as you put 1, I don't care. Then we have used in glass, jewelry, and electronics is quartz. And I apologize, they took this part off of the reference table, the polarizing, what did it say, polarizing prism, but they did still say used in cement. So use is cement or lime, not lime like that you drink, or not that you drink, lime like the fruit, I might drink a lot, no. Lime, like it's a chemical that, like I use it in my chicken coop.
Lime Lake?
Huh?
Like Lime Lake?
No, not like Lime Lake either. No, it's not a dumb question. It's calcium carbonate, which is calcite. I use it in my chicken coop, to prevent smells. Trying to think of, you can use it,
pH of soil.
there you go. So probably not a lime that you guys have used, but not the green limes that are like lemon. So just to be clear. So again, those were the answers to that. Did anybody have any questions? Pretty straightforward.
Yeah, I got them all.
You got them all right. That's good. I'm guessing you got them all right. As long as you did it and used your reference table, I'm sure you got them right.
I got them all.
All right, so what I'm gonna need you to do is flip open your packet to page 10 and your reference table to page 6. And again, we're gonna be using them basically side by side, so have them both out and both ready. Before we get started on learning about rocks, I wanna just kind of go back to minerals for a second. You guys feeling pretty confident with that minerals chart?
Pretty much.
Pretty much?
Yeah.
How you doing in lab?
Probably some other thing.
Decent, identifying the minerals? We're gonna have some more practice on that. I know Carter loves when I give tests, but I'm gonna give a quiz instead. So it'll be super short. No,
Do you have any candy?
huh?
Do you have any candy?
I do not have any. We are going to have a minerals quiz
Wow.
a long ways from now. I'm not sure why I'm even telling you now. We're not gonna have the quiz until next Wednesday.
It's not a long ways.
It's a week from now.
It's actually 6 days from now.
Okay. It's quite a few days from now. So we're gonna have this quiz on Wednesday for minerals. So that way you'll be done with the minerals lab by then. So hopefully you're all like practice stuff on minerals. We will review minerals on Tuesday next week, the day after not Thanksgiving, Halloween. All right,
Tuesday?
Tuesday we'll review.
Well, I'm gonna bring a bunch of candy to this class.
Okay, will you share?
Maybe.
All right, remember, you have to share.
With you, I don't have to show anyone else.
Okay, that's true. Sorry, guys. All right, we are now gonna talk about the rock cycle. We guys know about cycles. Okay, it's kind of like a repetitive circle. Process, does it ever end?
Yeah.
No, cycles never end. They just keep going and going and going and going. What other cycles have you learned about?
The life cycle?
Learn about the life cycle. Yes, but that's something different. So the life cycle, water cycle, now you're learning about the rock cycle. I don't want you to get these processes confused with what we learned about earlier in the year when we were talking about cyclic. So if you remember, cyclic was events that happened in a repeating pattern. They happened over and over again in the exact same pattern, which made them super predictable. These cycles that were just listed, yes, they happen over and over again, but it's more like a process, not an individual event, not like the letter days that happen over and over again. This is not quite the same thing. You can relate them, but this is not cyclic stuff. It's slightly different. So we're going to talk about the rock cycle. So before we do that, we should probably go back and review rocks. I hear you guys learned about rocks at Pioneer in 6th grade. I heard Mr. Allen. Does that ring a bell to any of you? You didn't have him. Who's the other 6th grade science teacher?
I don't know.
Okay, so do you guys remember doing rocks with her too? Yeah, no, and yes. It was a long time ago. So you guys learned about rocks a long time ago. But I bet you remember a few things about rocks. I would assume, did you also talk about them in 8th grade or no? A little bit. Oh, when you guys had that weird messed up 8th grade year. So I won't count on you remembering anything from 8th grade. But let's go back and see what you can remember about rocks. Give me anything you know.
They are different shapes.
They're different shapes. Okay, what do you remember, Jeff?
I think that it means
Sure.
like volcanic rock.
Yes, you guys, just, oh wow, I just said you guys twice in a row without even knowing it. Do you guys remember igneous rocks, that word?
No,
Nope, some of you, it's like a brand new word you've never heard of before in your life.
sedimentary.
Okay, so you remember sedimentary. So we got some people remember igneous, some people remember sedimentary. Does anybody remember the third one?
Metaphor.
Whoa,
That's right on the board.
Yeah,
Oh,
okay,
darn
okay.
it. Gave it all away. Is that where you guys all got your information from? No, you remembered some of it. Okay. So Jeff remembered igneous are from volcanoes. Perfect. Anybody remember anything else about the other two?
Sedimentary like the crust.
The some of the crust is sedimentary, but it depends on where you are. But yep. Could sedimentary rocks could contain bones, so fossils. That's real good.
So like asteroids,
No.
is that metaphor?
Metamorphic? No. Those are asteroids. What were you gonna say? Metamorphic are created by heat and pressure. All right, I don't even have to teach you guys. You guys remember everything you need
Oh,
to know.
perfect, study hall.
Perfect. So clearly somebody made you memorize all that stuff, right? Well, they must have at one point. You had to remember that igneous came from volcanoes, and that was probably a test question. No? I'm gonna call up Mr. Allen and ask him.
Go ahead.
Right now? I don't know his number right now. No, that's on the high school list. It's not the middle school. Anyway, good news for those of you who didn't remember anything that anybody just said. No, we're not gonna learn it again. You get a reference table for it. Because this year, you don't have to memorize much. Because, no, you don't. You don't have to memorize much because it's all in your reference
How
table.
was this a test there?
Because you get your reference table. Okay, no, well, we don't have the extra notes, you're right. But we do have a reference table. So if all of you could open up to page 6, that's where we're gonna start. Page 6, upper left-hand corner, rock cycle. So there's a lot going on here, but do any of the words sound familiar? What, okay. What about the 3 rocks that you guys just mentioned? Sedimentary, metamorphic, and igneous. What do you think the arrows are all about? It shows you where they go. Is that what you just said? The arrows show you where you're going. So if I was to draw an arrow up on the board, and the arrow went this way. So it's going to the right. So now I could say, well, follow the arrow, and you'd go to the right. Shows you where you're going. What happens if you read an arrow backwards?
You go backward.
It shows you where it came from. So if you read the arrow forward, it shows you where something's going. You had candy the whole time. So if you show the arrow forward, it shows where you're going. But if you read an arrow backwards, it shows you where you came from. The same thing is true on this rock cycle. So let's start with sedimentary rocks. So why doesn't everybody point to sedimentary rocks on the one in your front of you? And I'll do it up here so you can see. So everybody point to sedimentary rocks. Where could sedimentary rocks go? They could go to metamorphic. Is that the only arrow leaving sedimentary? So they could go, let me actually do this up here so if anybody watches the video. So sedimentary rocks could go, you guys said this one, they could go to metamorphic. They could go to magma, or what else? They could go over to sediments. So what does that mean? What could happen to a sedimentary rock? They could change, and they could change by getting heat and pressure, or they could change and they could melt, or they could change and turn into sediments. But let's read this backwards. What will reading these arrows backwards tell us about sedimentary
Where it
rocks?
came from.
It'll show you where sedimentary rocks come from. And by saying where a sedimentary rock comes from is the same as saying, how did a sedimentary rock form? So how many arrows are going, can we read backwards off of the sedimentary rock?
That would be,
There's only the one, there's only one arrow pointing to sedimentary rocks. So there's just one that goes into sedimentary rocks that we can read backwards. So where does sedimentary rocks come from? If we read this arrow backwards, they come from sediments. And what happens to sediments to make them sedimentary rocks? No, read the arrow that you just read backwards.
compassion.
Let's start from the beginning. So sediments, do you guys know what the word deposition means? It means to deposit. Okay, so what does it mean to deposit something? If I deposit money in the bank, what am I doing? Putting it there, leaving it there, dropping it off at the bank. That's what deposition means. It means to drop off. Burial. What does that mean? Put it in the ground, so it gets deposited, then it gets buried in the ground. Compaction, what does that mean?
It's all compacted together.
It's getting squished together. And what in the heck is that word? The word underneath compaction, what does it look like? Sedimentation. What's it look like?
Cement.
Looks like cement. What do you think it means?
About like solid, they're getting like mushed together and becoming solid.
Yeah, they're getting mushed together and becoming a solid rock. Basically, they're getting glued together or cemented together. But hold on. I don't think we ever said what a sediment is, though.
It's a rock.
It is a rock.
The weather and erosion.
It's a weathered and eroded rock. So it's a what? It's teeny tiny broken pieces.
Small version of the
Broken pieces of rock. I just put that little note in our my reference table. You might want to do the same thing. Sediments are just broken pieces of rocks. So if I ask you, how does a sedimentary rock form? Okay, can't just say sediments, because I asked how.
A weather and erosion.
What does weathering and erosion make?
Of broken pieces of rock.
Weathering and erosion makes broken pieces of rocks.
That's
I
what
asked-
that is, though.
But I didn't ask what sediments are. I asked, how do sedimentary rocks form?
You said sediments.
Yep. Did I?
Yeah, you know.
Let me rephrase my question. We can play back the video later. I'll prove it what I said, and I might be wrong and you might be wrong. Who knows? So let me rephrase my question in case I screwed up. How do sedimentary rocks form?
They all get compacted together.
What's they?
The rocks, the broken pieces of rocks. Sediment.
Okay, let's everybody take a deep breath. Close your mouth. Don't say anything. And every last one of you think of an answer before you shout anything out, and then I'll call on you. So here's my question for a third time. How do sedimentary rocks form? Don't say anything out loud. Form an answer in your head. Hint, read it off the reference table. Now who wants to volunteer to tell me how sedimentary rocks form? Is that a volunteer?
Yeah.
Oh, Sarah wants to do it.
Sarah?
Sarah, how do sedimentary rocks form?
Sediment.
Stop saying sediments.
That's true, though.
That's not an answer. That's another word. I want to know how. Sarah, go ahead. You can start off with sediments, yes, but it's not the end of the sentence. So yes, sediments, what happens to sediments, Sarah?
They deposit into each other and then compact and they get stuck together.
Okay, we need that whole sentence. We can't just have a one-word answer of sediments.
You said it once, and you just-
So- I interrupted you. I could have. I apologize for interrupting you.
Exactly, you gotta-
Right here in your notes, it says, describe how each of the following rocks form. Sarah just walked us through sedimentary rocks. Again, do you have to memorize what Sarah said? You do not. Sarah, what'd you do to get that answer? And how did you read it off the reference table? Okay, so for any time we want to know how a rock forms, you go to that rock and you read the line backwards. So sedimentary rocks form when sediments get deposited, buried, compacted, and cemented together. I'll write that all out. Starts with sediments, and this is all on your reference table. Sediments get deposited, buried.
Do they all come into one? Like, at the end, do they all come into, they all form into like one drop?
What if they are you speaking of?
Like the broken pieces, because they all get buried and smushed together, so they all
Mhm.
get put into one rock, right?
Mhm. Yes,
Come on, Dwayne.
so all those broken pieces get buried, compacted, and cemented together. Yeah, and not just say sediments. We're getting technical. When I ask how something forms, you can't answer with just a noun. Like I can't say, hey, Zach, how did you get to school? You can't just
Car.
say,
A car.
okay, car, what did the car do? Drove here. Okay, how did you get to school? We need a verb, okay? Can't, a how, when I say how, I need a process or a verb. I cannot just answer with a noun. Okay,
What if we said walk? Because what if we live right
that's
there?
not a noun, so that's a verb. Thing,
Yeah.
yeah.
Now
Now you're freaking messing with me. All right, so here's your next one. Paying attention, Cadence? You ready?
I was just sleeping.
You want to do it?
Come on, kid.
No, all right. Everybody do this one together. Same idea. Form the thought. Every one of you form the thought. Not just a few people who are going to be willing to answer me. We're going to do the same thing for igneous. So start by putting your finger on igneous rocks.
Magma turned into solidification.
Okay, again, I wanted everybody to form a thought in their head before they spoke. So everybody
I
point,
did form a thought.
but okay, so wait till I call on you.
Oh.
Speak it out loud. Everybody point to igneous. How do we read this to figure out how it formed? Answer out loud.
Follow the arrow back to magma.
Oh, love it. So find igneous. Read the arrows backwards to tell me how it formed.
Igneous melt.
No, Cadence is gonna do it because she's got, I see you pointing to the right things. How does an igneous? So igneous rocks, read it backwards. They form by the solidification. So igneous rocks, read it backwards, form from the solidification of magma. What the heck does solidification mean? It does say solidification. It means to solidify, which means to turn into a solid. Yep. So we have, oh wait, do you guys know what magma is?
It's a metaphor.
No, it's a melted rock. Yeah, it's melted rock. Magma is technically melted rock on the inside of Earth. We'll get to that later. And there's melting there. So how can we put in a nice, neat phrase, everything that has to happen for an igneous rock to form?
Just solidification.
So just solidification, that's it?
Yeah.
Of magma, there's one more thing I'm gonna need though. Where's the magma come from?
Magma.
Metamorphic rock.
Not necessarily,
Melting of the metamorphic rock.
not necessarily.
Melting of the metamorphic.
Melting of the igneous rock.
Guys can look at this.
Melting of magma.
Melting of, no.
Okay,
this is
stop.
Sedimentary rock.
Wait, okay, so you guys seem to be having a misunderstanding here. Do you see all these different arrows of all these meltings?
Yeah.
Here's a melting arrow. Here's a melting arrow. Here's a melting arrow. What do you notice?
They're all going to magma.
Wait, but where did they all come from?
Magma.
No, where did all these arrows
Different
come
place
from?
to laugh.
Metamorphic or sedimentary or igneous rocks can all melt. So any rock can melt, turn into metamorphic, or, oh man, any rock can melt, turn into magma, then it solidifies and hardens into an igneous rock. So how do igneous rocks form?
All
They
around.
form from the melting and solidification of magma. But keep in mind, guys, any rock can melt. Any rock, doesn't matter where it came from. Any of the rocks can melt. Where's the other one? Into magma.
Ain't the rock like this.
No, we're not there yet.
Kidding.
Metamorphic rocks, same idea. How do all metamorphic rocks
All
form?
year back to sedimentary.
Wait, do they only go back to sedimentary?
Yeah. No, just kidding, igneous.
There's 3 arrows pointing to metamorphic as well. There is
The one
igneous,
doesn't even have any-
yeah, but what's it point to?
Some points to it.
Points to the arrow. So an igneous rock can get heat and pressure and turn into a metamorphic rock. A sedimentary rock can melt and turn into a metamorphic rock. And then, not melt, sorry. An igneous rock can get heat and pressure and turn into a metamorphic rock. A sedimentary rock can get heat and pressure and turn into a metamorphic rock. Or one metamorphic rock can get heat and pressure and turn into another metamorphic rock. So how do metamorphic rocks form?
Heat and pressure.
Heat and pressure. Before we keep going with this, I have a few more questions to make sure that you guys, and I'm gonna get one that I don't have highlighted.
Wait, doesn't. Sedimentary.
No, we're not doing the questions right now. I want to make sure you guys understand a few things.
I understand everything.
Okay, Carter. Carter, how does a sedimentary rock turn into an igneous rock? So here, I'll even put some stars up here.
Sunlight.
No, stop. First of all, I called him Carter. How does a sedimentary rock turn into an igneous rock?
It goes through heat and pressure to the metamorphic rock, and then it melts to a magma rock, and then it solidification to a.
So you're telling me the only way to become an igneous rock is for a sedimentary rock to first become a metamorphic rock?
No,
No, then why do you say that?
because I just followed the arrows. There's multiple arrows that goes through.
So what my question to you was not how does a sedimentary rock become a metamorphic rock, then an igneous rock? I asked you, how does a sedimentary rock become an igneous rock?
Isn't it by,
You knew everything, Carter.
I
You
do know
didn't
everything.
even have to pay attention to me so much that you already knew all the answers.
I don't.
Keith, how does a sedimentary rock become an igneous rock? Can sedimentary rock just up and melt whenever it feels like it?
Yeah.
100%, follow the arrows. Igneous rock
just-
melts into magma, solidifies into an igneous rock. So Carter, do I have to stop at metamorphic rocks to become an igneous rock?
No, but you said that was wrong.
No, you told me sedimentary rock gets heat and pressure, turns into a metamorphic rock. Don't do that. Zach, I will kick you out. Sarah, I will kick you out. Sedimentary rocks do not have to do anything in the metamorphic side to become igneous. They take the fastest path there. So let's try another one. Again, everybody get an answer in your head before you raise your hand to answer. How does a metamorphic rock turn into a sedimentary rock? How does a metamorphic rock turn into a sedimentary rock? Hint, did I say anything about igneous? I did not. So if your answer has something to do with igneous, please fix your answer. Did you figure it out? You want to do it?
I can try.
Try. That's the best you can do. This is our first day doing this. It's okay to make mistakes. So saying you're going to try is different than saying, I got this and I don't need you to teach me anymore. Go ahead.
So I saw, I don't know.
What did I say? Metamorphic?
Yeah. I
Goes.
saw the metamorphic rock to the sediment. It goes all the way back around to the sedimentary rock. Which can
That's
also
it.
be-
So for a metamorphic rock, it just gets weathered and eroded, which means it gets broken into sediments. Those sediments get deposited, buried, compacted, and cemented together. Okay? Take whatever path is the fastest to where you're going. How about this? How does a metamorphic rock turn into an igneous rock? Don't say sediments. Destiny, do you see this one? How does a metamorphic rock turn into an igneous rock? This one? This one? That's the fastest path there. Melting in the magma and solidification. So that one, you just follow the outside. So you don't have to go around the outside, just take whatever path gets you to where you're going the fastest. So in our notes, the next question asks, which rock, name the rock that comes directly from other rocks. Let me rephrase this with an example you might understand. If I tell you to go directly to the office, what's that mean to you?
Stop at the bathroom, get a drink, then go to the office.
Perfect example of what I didn't mean. Thanks for confusing people. When I say go directly to the office, it means don't make any stops. No side tracks, no side trips, no pit stops. You go directly there. I should be able to watch the camera and have you travel straight there. Okay? So which one of these rock types can go from being itself with no stops, or which one goes to becoming itself with no stops in between? Jeff, do you see? Igneous to metamorphic does not require a stop. Is there any more changes that do not
Yeah.
require a stop? Sedimentary to metamorphic, there's one more. No, because that's not a rock type. So, but you're right, there is no stop there. But rock to rock. Don't forget this guy here. That's one metamorphic rock going into another metamorphic rock. So to answer the question, which rock type comes directly from other rocks? Metamorphic comes directly from other rocks without making any pit stops in between. Everybody else, sedimentary, they have to stop at sediments before they turn into sedimentary rock. Igneous has to stop at magma before it becomes another rock. How about this one? Which one comes from magma? Yep. So which one comes from magma? Here's magma. It goes to igneous. So igneous comes from magma. No. Which rock type comes from sediments? Sedimentary. I know. What are 3 things that can happen to any rock? Let's take this apart,
Weather.
okay? All three rocks can get weathered, Zach says. There's weathering, there's weathering, there's weathering. All three rocks can get weathered. What's another thing that all three rocks can do? I heard melt. Igneous rocks can melt. Sedimentary rocks can melt. Metamorphic rocks can melt. And what is the third thing that all three rock types can do? What's the third thing all three can do? We already did, well, break is weathering and erosion is gonna break them. Was the only thing that we haven't talked about. All three rock types can? No, we already did that. Heat and pressure. Sedimentary rocks can get heat and pressure. Igneous rocks can get heat and pressure, or metamorphic rocks can get heat and pressure. So what can happen to all three rock types? They could get heat. They could get heat and pressure. What's another one? They can all melt, and they can all do weathering and erosion. All right, you guys are gonna have homework tonight.
Yeah.
Who's to guess about that?
Back to this and back to the other. You like it, so you can't judge me.
Your homework is
Okay,
going to
okay.
be pages 10 and 11. 10 and 11, it is
9 to 11.
8 questions long.
That's too easy.
Zach, come here, we're gonna take like be real. Miss Rich, did you take yours already?
I did not, and not after that disaster one from yesterday.
You only got carded for it.
They have my whole thing.
Because